Hello ladies and gentlemen, my name is Decryption and I hope you are well. We made a door that is very optimised and can load and unload interiors. It's great for dungeon crawlers, or in my use case, interiors of houses. Entire actors just spawn in using data layers. However, the data layer aspect is good, but if you're going into a dungeon or something like that, then the door opening and closing shouldn't really use a data layer, because you can, but a lot of games teleport you to it, and sometimes it's a lot easier to do so. So for example, I have a castle that has vanished. Let's put the data layer back on. I have a castle here, a large kingdom thing, that's going to have NPCs walking around, sounds, noises, stuff like that. But when you're in the castle, which is a very large castle I might add, so as you can see we've got stairs, we've got loads of different doors, we've got places we can go, we can look out, we can come up, there's loads of rooms, loads of stuff we need to do. I don't necessarily need all of this here. I don't need half of the world here either. So we can technically unload all of that. Equally, if you go into a cave or a dungeon, you'll want to unload it. So games like Skyrim, as you go in and out of interiors or dungeons, it will physically change levels. So it doesn't have to load and unload everything. It's a very optimised technique, and it's something we're going to look at today. So let's get started. We already have this door here which is going to open and close this interior, and that's all good. I don't actually have a dungeon door or anything like that yet, and I've not moved the castle to its own map. But what we're going to do is we're going to fake it, and we're going to pretend there's a cave here. And then I believe the tool I'm using for world creation is planning to add caves, and then I'll be able to work on it from there. So what I'm going to do is I'm going to come and grab my elven door here, and I'm going to duplicate it, and I'm going to simply call it Dungeon Door 1. And we'll drag this out over here. We'll pretend there's a dungeon here. I'll rotate it in place. I will say a prerequisite to this is you kind of need to have followed the previous video to follow this, because it sets a lot of the groundwork for the door we're going to do. So now that we've got the dungeon door, that's the one we're going to interact with. I'm going to go back to our BPA door here. Now this entire thing at the moment is coded to work with data layers, so it's using the data layer manager. But what we can do instead is we can tell it when interacted, if a map is provided, we can use the map instead. And it's actually really easy to do, but it will require us changing our code a little bit. So if you don't have this download, feel free to go back to the previous video and download the finished product from there. So what I'm going to do is right after we call door state change, which is the code which plays the sound and deactivates the door, we're going to check whether we need to use a map or not. So I'm going to take the door state change part here, and I'm just going to move it up out of the way. And I'm going to move this part of the code down for the data layer. Let's make some space. I'll add a custom event to the data layer part called load data layer. And we'll connect that in like so. And then up here, let's first check if we've assigned a data layer to load. So I'll drag off our data layer and do is valid. And we'll do the question mark one. And this is going to tell us, have we assigned one or not? We'll plug that in here. If we have assigned one, then we simply want to call load data layer. Load data layer, like so. And then that's all we have to do with that one. If we've not assigned one, then we need to check whether we have assigned a map or not, so we can start the fading process. So I'm going to come all the way down to the bottom, and I'm going to add a custom event called load map change instead. And then we'll call this one back at the top while we're here, so we don't forget. Load map change. There we go. Double click it to go down to it. So in here, we need to start the camera fading. So if you've got some UI you want to use for that, you can. I'm just going to do a simple Unreal fade, which fades out and then takes us to the new level. So we know we want to load a map. So what I'm actually going to do is disable the player's input first, so they can't move around. I'm going to type get player controller, and then from this I'm just going to drag off and do disable input like so. And it'll ask us which controller to do. We want to do both like that. And then it's also asking for an actor, so the player controller will disable the input on that if you've got any controls on that. We also want to disable the player's pawns controls, so we can also plug that into target. So both on the controller and the pawn, whilst we're changing maps, we'll disable their input, so you can't walk around and stuff. Whereas with the data layer, it doesn't specifically matter. After the input, we can right click and do get player camera manager, and we can drag off this and call start camera fade, like so. You can also add camera logic if you want. You can start a sequence if you want to zoom out, anything you really want to. So I'm going to say from the alpha is 0, which means you can see 0 is fully transparent. 1 is black, so we'll make it completely black so the player can't see. The duration, we'll set it to, I don't know, how long do you want it to fade? We'll say 1 second. Should it fade the audio? Yes. And should it hold when finished? Yes, we will do that. So what that's going to do is when you get to the black part, before it will just instantly set it back to normal. However, hold when finished means it remains black until we specifically tell it stop camera fade, or you change levels, I believe also does it. So once we've faded there, we need a way to tell when the fade has finished. Unfortunately, from the camera manager, there is no events we can bind to for when the camera is finished fading. We've got one for the audio, but if you fade the audio via other means, we don't really want that happening either. So what we're actually going to do is just simply run a timer. So off of this start camera fade, we will call set timer by event. And the time, we'll just set it to the same duration there, but I'm going to set it to 1.2. So it fades to black, then it does it. There's no chance it will be on like 0.999, then it'll do it where you can just see a tiny bit. It will fade to 1, then do it after like 0.22 of a second. From the event, we'll drag off and just do add custom event called load map. We don't want it looping, and we can really ignore all of that there. Then from here, I'm simply going to drag off called open level, and I'm going to do by object reference, because I like that one. And this one here, it wants a soft object reference, so we'll promote that to a variable called map to load. We'll make it instance editable so we can see it, and that's really all you have to do. So if I compile and save and come back to my dungeon door here, let's come back to the map to load. I'll clear off the data asset because we don't want one in there, because we don't want it loading a data asset. The map to load, however, what have I got apart from a bunch of random maps that I need to clear up? Let's have a look. We've got a dev map. Let's go to our tent burning one. Yeah, that'll do. So now let's try it. So in theory, if we interact with that door, which we'll start with, it should just start the data layer and then hide the data layer. So let's try it. We come up. There's no map. It works perfectly fine. That's all good. However, if we come over to this one and we enter the dungeon by opening the door, you should see it should fade to black and transport us to the new map. There we go. It fades out and then boom. We've got everything back. We are back in the new map. How cool is that? So we can come, we can do the dungeon. I can get a breakpoint apparently. Oh, and then I've been told to go away. I think that was some debug code I was running. But we could have another door here that'll take us back to the other one. Let's do that because that sounds pretty cool. So I'm going to come over here. I'm going to grab this door right here. Copy it. I'll come to my tent burning one to pretend like it's a dungeon, which I will add eventually because that sounds cool. It's added the door somewhere. Let's center align it because it seems to be way off. There we go. So we'll place this one here. And instead of it going back to the tent burning one, we need it to go back to the main map, which for me is the landscape WP for world partition. Let's try it. So we'll open the landscape map. There we are. So you'll see when I come back here, I can right click play from here. And now when I run over to this map over here, if we start this door, it will teleport us into the new map. It will load and we are here. Let's, we'll run over, we'll burn the tent because that's what our quest is inside this dungeon apparently. The tent is now on fire. It will crumple. Then, there we go. We can now loot it. Good, we've finished the dungeon. Dungeon complete. We run back, open the door. It'll fade out and then we will be set back into the landscape, which will take some time. Boom. We are now back in the landscape. But you will have noticed it's put us at the wrong place. And that's because it's just simply loaded the world and put the player back where they need to be. Whereas we need the player to be specifically at the correct point in time. At the correct place they started and entered from. So in this map, we know it needs to be in front of this door here. So it kind of needs to be like here, because we've just came out of there, because that's going to make more sense, isn't it? So let's have a look at doing that. So we need a way to transport data between levels, keeping it. Now you could set an actor to be persistent throughout it, such as the door, for instance, I'm going to take the much easier approach and just use a game instance instead. A game instance is something that starts as soon as you start the game, and it will remain throughout the entire game for you transporting data. I believe it settings and stuff like that transports over with it. I use it to transport save game names across levels, and then when you've quit the game, it gets rid. So you've got to be on top of cleaning it up and make sure you don't transport anything heavy with it. But it's super simple to do. All you need to do, I believe I've already got one. Yeah, so I've already got one here. But all you need to do is right-click Blueprint Class. Inside here, search for Game Instance and create a game instance there. And then we'll open it up. So I've got the faction stuff in here. What you also need to do is go to Edit Project Settings. And inside Maps and Modes, make sure you've assigned your game instance down at the bottom there. There's many ways we can do this, such as adding a vector to the world, so it literally says, come to this vector. But if your artists ever move it around, like if I take that over here, then all of a sudden that vector is broken. And in games design, things are going to change all the time. So we need to try and limit this as much as we can. So instead of doing that, what I'm going to do is simply add a tag to this door so we can find it again. And I'm going to add a little token to say, put the player right here. Alternatively, if you don't like the tag approach, you can use gameplay tags, or you can use a data table which contains all the relevant info from this dungeon to this dungeon. There's loads of different ways. So what I'm going to do on this door here is I'm going to come and, well, I'm going to give it a tag just here, really. So I'll call it Dungeon Door 1, and that's how we set an actor tag. But now we need to set a token to where the player's going to spawn back in. So on the BPA door here, I'm going to come and add a variable called player spawn location, and I will set this to a type of vector. Now I know we said we weren't going to use vectors, but this is going to be a different vector because this is going to be a relative vector. So I'll actually change this map player to spawn so we know them two are assigned together, because we don't want it to spawn when the player loads a data layer. That's going to be odd. So on this vector, I'm going to come and tick show 3D widget, because that's something we did as part of the racing script. And all that does is gives us this nice little token here. So we don't have to manually change the vector. It will do it for us. But what this means now is I can come and drag this and place it right where I want the player to spawn. Right about there, I think. I'll probably do. We'll have to test it. But you can see it updated the vector. But this vector here is not in the world. The world position is 13,000. But this is relative to the door, which means if I move the door over here, you can see those numbers, they will stay the same, meaning the player will always remain in that spot, no matter where you move it to. So now that we've got that, all we need to do is on our game instance is add a variable called map_door2spawn, and I will set this to a type of string, because I believe that's what tags are. To test that, let's just go to a blueprint and type get actor tags, and if you hover over it, it says yes, an array. Add it, you'll see it's an array of names. Okay, it's a name, not a string. So back in our game instance, we'll just come and set this to a name. There we go. And I'll need to check this out, make writable. And there we go. So now, what we can do is back on our door, if we load the map here by going to open level, what we can do is we can get the tag on this door, if it's got one. So that was the tag we added here, dungeon door. We can assign it to the game instance, and then when we load the player in, we can find the actor that's got that tag and then spawn them at that target point. So we need a way to set this. Now normally you can just get the game instance by typing get game instance and then cast to it, but we don't like casting here. So what I'm going to do instead is find my interface for my game instance, which is just an interface I've created before. In here, I will add two functions. The first one will be set map player spawn point, and this will have an input of a name. I'll call spawn point tag, and it'll be a type of name. And then it will also have an output of get map player spawn point, which will have an output called spawn point tag, and it'll be a type of name. Back on our game instance, we can now implement these functions like so. So on the get, we will simply return the variable. On the set, we can simply set the variable like so. So that's the part where we set and load it from the game instance. Let's actually call that. So on our BPA door, on the game instance, simply go set map player spawn point, connect it all up before we call open level. Then the spawn point tag we want, let's just right click and do get actor tags. We know we've got a first one, so we can connect it up. Equally, if you're not sure if you want to prevent against errors, do is valid index 0, and then we can check it in a branch before we call anything. So if I just make this a bit cleaner, all this is going to do is if a developer's forgot to add a tag, then we can throw an error instead of teleporting it. So if it's valid, true, it means it's found the tag. If it's invalid, false, then what we'll do is print out and say error, no tag assigned to this door. So if we forget, at least it'll tell us like so. So now that we've assigned the tag to the door, so we know which door to go to, let's jump back into our other map, my map, so it can find the relevant door to go to. So you'll always have two doors named the same thing, but they're on different levels, because then that's how you can connect the doors. Equally, you can do two variables, door from, door to. I'm not going to bother with that one. So here, I think that door's backwards actually, so we'll rotate that around, like so. And then if we double click this token again, we can tell the player where they need to be. So we'll say about there. To make this easier going forwards, what I'm actually going to do is copy that vector, and on the door here, on the vector, I'm actually going to paste it as a default value. So then all that means is any door we drag out going forwards, they'll always have that target position placed in the right place, which will be nice. And then this, we'll make sure we've got the right tag on it, which we don't. So we'll come and call it Dungeon Door 1, I think the other tag was. And now if we jump back to the other level, so now back in this level, the last thing we need to do is actually tell the player to actually listen to this point. If it's got a spawn point, we actually need to tell the player to listen to it and go to that point. So there's loads of places you can do this, but we need something that's going to follow the player along. So we're not going to do it in the map level blueprint here, because otherwise we'd have to do it on every single level blueprint. I'm actually just going to do it on the player controller instead. So I'm going to go to the player controller, I'm going to open this up. If you don't have a player controller, simply right click blueprint class, player controller, and then in your game mode, just set your player controller there. That's all you need to do. And then on event begin play, I'm changing my name, I'm adding my HUD, which is all perfect. But then what I'm also going to do is get the game instance. Then I'm going to check by getting the map player spawn point. I'm going to check if it's empty, so equals blank. If it's blank, then we've not set one, so we can ignore it. So I'm just going to ignore that one. However, if it's not blank, then it means we've found an actor. So on false, I'm going to get all actors of class with tag. So it's going to be a type of our door. So our BPA door parent. The tag will be a spawn point tag here. And then we'll drag off of this and do get. Before we do anything with the get, we will check if it's a valid index. Again, just to make sure the developers not accidentally forget to assign it. If it's false, then we can copy the error from the door. So we'll paste it on the false. However, if it's true, then we can simply take the actor here. We can get the spawn vector, so the player map spawn location. And then we can simply come in here and we can say get player pawn. And then set actor location. So connect that to true. We'll drag this below here because it'll look a bit neater. And we'll plug that into the vector here. And in theory, that's it, ladies and gentlemen. We now have a way of going into a dungeon and it telling us specifically where to spawn the player. So let's try it. So if we jump into the game now, as we go into the dungeon, it should take us to the new level and put us in front of the door. So if we open it, you'll see we're off to the side. It's not done anything. How come? So it has technically worked. The start point of this map is something like here. And it's moved us this distance across here, which is not the correct one. What it's doing is setting us to the relative position of the door, but in world space. That kind of doesn't make sense. So basically, it's taking this position here, this vector, which is 70, 130, and 100, and putting it directly in here. That's not right. We need to go to this position, but with this vector included. So it's actually a really simple fix. On our player controller, instead of assigning this vector to this new location, we need to transform this vector from a relative to the door to world space. And the easiest way to do it is drag off of here and do transform location and plug the return value into our location. And the transform will simply be our doors get actor transform, and we plug it in. And that's it. Now it should all sync up perfectly. If you've got it too low, you will fall through the floor, so just make sure you lift it up a little bit. So this will help if you want to spawn in any tight spaces. So if we open it now, you should see we will spawn directly where we've told it to. There we go. We've just come through that door. If we come back through this door here, after the long delay of loading the big level, and don't forget this will be covered up with loading screens if you've got async loading screen installed, we are outside the door. How cool is that, ladies and gentlemen? If we want to do the rotation as well, it's pretty much the same thing. So back on our player controller, so to set the rotation of the player, we actually have to do it a little bit differently. So I'm going to come and get the player controller, and instead I'm going to set the control rotation, because the controller in most cases decides what rotation your player is. And the rotation, I will simply drag off of the door, I will simply do break off of the transform, and I will plug the rotation in like so. So in theory, we should now face the correct direction of the door. So if the door's facing outwards, we should be facing outwards. So if we go in now, as it spawns us, we are facing the direction of the door. So because the door's sideways, we are also facing sideways. So we need to rotate it around just a little bit. But you can see we are almost there. We just need to rotate it by 90 degrees. So back on our player controller. So to rotate it by 90 degrees, I'm going to unpin these. I'm going to split both of them, plug in the X, plug in the Y. But on the Z axis, I will plus onto it and we'll just say add an extra 90 to counteract the door's rotation. If this doesn't work, we'll try minus 90 and that should work. So let's play from here and see how we go. So now if we come in, we're facing the door. It shouldn't matter which way we go because we should always face outwards. There we go. We'll come back in, we'll open the door again. And we are facing, hopefully, outwards. There we go, ladies and gentlemen. How cool is that? We now can enter dungeons in and out. We are facing the correct way. Loading screens will cover it up. How cool is that? There we go. My character's not facing the right way when we drop, and that's simply just because this is a bit too low. So I'll move it up a little bit, pull it out a little bit, and we should be fine. So there we go, ladies and gentlemen. There is our door system optimization tool. We can now jump between maps, we can jump between data layers, we can efficiently make our game work. It is getting closer to becoming a real game. We have a big announcement coming on the channel soon for this game and other cool things, so subscribe to see that. Please consider leaving a like and maybe subscribing if you do. Thank you for watching, ladies and gentlemen. I hope this helped. If you want to see any of the videos early, please consider subscribing to the Patreon because I do release the videos sometimes a week early if I'm running late, sometimes 6-7 weeks if I've got a nice bulk recording session going on. Thank you for watching, ladies and gentlemen. My name is Decryption and I will see you next time.